So as we look at some more examples here, trying to find the composite area, keep in mind, got a couple things going on. We've already kind of done some problems. We'll see maybe another one of them where we have to subtract, right? We have the area of something and it's like a hole's punched out of it or a section's missing of it. So we take the area of the whole thing, subtract out what we don't want. But as you can see in example 2 here, we're going to probably need to add some things on. Okay, so again, we're going to be adding or subtracting areas. And really just try to think it through and do what makes sense. I don't know, I got a window shaped figure here. I don't know. I don't have an area formula for that. But what I do know is that I can break this up because it says its area figure consists of a rectangle with a semicircle on top. So if I break this up into the rectangle and semicircle, I can find the area of each one and then add them together, right? Area of this plus area of this. So if I take my rectangle right here, okay, and my advice to you, it's going to be like this always, is always redraw what you want. Maybe. Okay. Redraw what you want. You don't have to put it on there and make it perfect. It really doesn't matter. I have the ability to do that with my software. So anyway, if I redraw what I want, I know my bottom here is going to be 4. Right? There we go. Okay. What I have to figure out, though, is how long is this side over here? All right. Well, that's a little tricky. So let's go to our semicircle, and that's going to help us figure out how tall this is, because I know this whole thing is 7.5, but I don't want the whole thing. I only want to here. Okay, so if I draw a semicircle, and I totally cannot cheat on that one, right? I don't have a semicircle button, so squint and pretend that this really bad semicircle here, maybe if I make it thick, right, it'll help. Okay, let's pretend that this right here, okay, is this top part right here. So I'm going to find an area of a semicircle, right? So if I need area of a semicircle, I need to go pi times our radius squared. But remember, that would be the whole circle, and I only want half of it, so I'm going to divide it by 2. I need to know the radius. How can I figure out the radius? Well, this right here, this bottom, is how long? It's 4, right? 4 meters. But I want the radius. That's the diameter. The radius is only half of that. So my radius is 2. Okay, so I know my radius is 2. So I could figure this out. And I could go pi times 2 squared divided by 2. And as you were working on before, typing that into a calculator, 2 times 2 is 4. So that would be 4 times pi divided by 2. And that works out to be 2 pi, which is approximately equal to 6.28. Okay, so again, you guys, I know I have note sheets here where I'm just copying down from, but this is the stuff you were doing in a previous lesson. So just typing into a calculator and figuring out what it means. All right, so I know this area right here, but I gotta somehow find this height right here. Well, what I want you to remember is our definition of radius. Our definition of radius says it's from the center to the outside. But it doesn't matter where. It's from the center to the outside. It's from the center to the outside. Now, if we stop there, if our radius, our distance from here to here is 2, that means I can cut off that 2 feet. And that my distance from here then to here is 7.5, the whole thing minus 2. And that makes it 5.5. Okay, that one's tricky. I get it. But it's understanding your definition of radius. That's why I definitely want to do this problem with you. It doesn't look like we have enough information. But if you remember, oh, radius of a circle is going to be the same anywhere from the center to the outside. That means the height of the circle, or half semicircle here, is 2. So then we know our side over here is 5.5. Now, super easy to find the area, right? Area of a rectangle is just length times width. So that's 4 times 5.5, or again, 5.5 times 4, it doesn't matter. Type that into a calculator, you get 22. Now, in the last examples, we were subtracting. But remember, I want this whole thing here. This is 22 square meters. This is about 6.28 square meters. I want to add it together. So I'm going to go 22 plus 6.28, and that's going to equal 28.28. And again, area is always square meters. Sorry, I squeezed that in there. Okay. This case, though, we're adding because I have on the area of two pieces, putting it together. All right. So moving on to this one. So again, it wants the area of the shaded region. This whole thing is shaded. Excuse me. It says we use 3.14 per pi. You can do that. I'm going to just probably use the pi key. Obviously, this is not what I'm going to subtract. I don't have a tilted ice cream cone here. I don't even know. I don't have an area formula for area of that shape. But what I do have is I have a formula for this area of a triangle, and I have a formula for area of a semicircle. Always helps, guys, to redraw things. And this is not going to be perfect. It doesn't have to be perfect, but it's helpful because it doesn't seem, maybe, at least to me, not quite so overwhelming, right? This right here is 14. To find the area of a triangle, I need to take base times height and divide it by 2. Or remember, 1/2 times base times height. The previous notes, okay? I have the base, I need the height. Dang it, here we go again, right? So, I'm going to maybe draw my picture here of my semicircle. And you guys are going to squint for me because it's going to be really, oh, not too bad. We're going to stop there. Best I can get it. Notice it tells us the distance from here to here is 4 centimeters, right? Well, that's our radius. The distance from the center to the outside, no matter where, that's our radius. So if I know this is 4, that also means that anywhere is 4, including this right here. That's 4. Well, including this right here, that's 4. So if this is 4 and this is 4, guess what? This whole thing is 8. The whole thing is 8. Okay, knowing that definition of radius really helps here. Okay, so let's do this formula real quick, right? So this is going to become 14 times 8 divided by 2. Type that into a calculator, or 14 times 8 times a half, you get 56. Now over here, our area of a semicircle, okay, is pi times our radius squared divided by 2, because we want half of it. So I go pi times 4, that's our radius, squared divided by 2. And when you type this into a calculator, you get 4 times 4, which is 16. 16 pi divided by 2. And that's going to be approximately equal to 25.13. Okay? Now, am I adding or subtracting here? Well, area of this is 56. The area of this is 25.13. If I want it all together, I'm going to add it. And get a composite area of 81, or approximately 81.13 square centimeters, because it's in centimeters and areas in squares. How many little squares? Okay. All right, let's look at one more example. All right, pay very close attention to this one, okay? Because you might see this in the future. I don't know if it's necessarily in your homework, but you run into it on any standardized testing. We have a tilted almost triangle here, so I can't find the area of a triangle because I don't know the base and the height. So we need to find the area of just this triangle. Okay, now notice it says redraw the figures separate triangles, then label the lengths discussing calculations. All right, here, just stick with me right now. I want to find just the shaded area in here, right? So if I take the area of the whole thing and subtract off what I don't want, which are right triangles, then I can find out what's left over. Okay, stick with me. This area of this rectangle right here, that's not a rectangle, sorry. Click the right button, okay? And it's not going to be the same size. Don't worry about that, okay? Area, this right here is 20, and this side right here is 20. So our area formula, again, is just length times width. Well, that's 20 times 20, which is 400, okay? So I know the whole thing is 400. Now I want to break up the triangles, okay? So let's start maybe with this triangle right here. That's not what I wanted. Let me try again, sorry. This one right here. All right. So if I take this triangle right here, oops, sorry, undo. Not what I meant. Not what I meant to copy. Let me try that again. I actually want to leave this up here. Okay, so we remember we've done it. Okay, so if I redraw this triangle, it has a height of 20, and it's a right triangle because it's in the corner there. And what is this distance from here to here? Well, the whole thing is 20, but from here it's 8. So 20 minus 8, that means this has to be 12, because 12 plus 8 would equal 20. Okay? So if I want to find the area of this triangle, area of a triangle is base times height divided by 2. So I'm going to go 20 times 12 and divide it by 2. And I'm going to grab a calculator and I'm going to do that. And I am going to get 120. Okay? So this is 100 and area is 120. So now let's maybe try this triangle right here. Oh, shoot. Let me start again. Nope, let me start again. Oh, sorry, guys. There we go. Just got to get it to go the right way. Okay? So if I have this triangle, okay, again, not going to be perfect, and that's okay. No. All right. This whole top here is 20, and this right here, well, remember, it's 20. This is 6, so this has to be 14, because 14 plus 6 is 20. Okay? I'm going to use the same formula, base times height divided by 2, and I'm going to go 20 times 14, base times height, always around the right angle, even though it seems like it's on the top, it's still the base, divided by 2, type that into a calculator, and I'm going to get 140. So this right here is 140. Now we have one more left. And, nope, you remember how to do it here, right? There we go, okay? And this one right here, around our right angle, is height of 6 and a length of 8. So using the same formula again, I'm going to go 8 times 6 and divide it by 2. And when I type that into a calculator, I get 24. So if I want just the area of the shaded part here, remember I'm going to take my 400 and I am going to subtract off all of these. Or you can think of it as I'm adding these up and then subtracting them. However you want to do it, maybe I'll do that. I'm going to subtract off all these added together. 120 plus 140 plus 24. Or you could just go minus, minus, minus. That works out to be 400 minus, when I add all these up, that's 284. And that gives us 116 square centimeters. Okay. I know that was kind of a long problem, but I want you to see that when we're dealing with composite area problems, sometimes we're going to take the whole thing and we're going to have to subtract off pieces to get what we want. Sometimes, like in the previous problems, we're going to have to find the area of different pieces and then add them together.